Whoa, let's solve some radical inequalities. Okay, so hopefully you just graphed some radical functions and now you're needing to solve some radical inequalities. Okay, so I'm just going to start you off with kind of an easy one, the one that I hope that we can kind of just think about and think about values of x that would make this inequality true. What values of x make the square root of x greater than 8? Okay. We know that the square root of 64 is equal to 8. So I feel like if we put in anything bigger than 64 into square root, we'd get something back bigger than 8. And that is true because square root is what we would call an increasing function. And so what I would say is, okay, well, we're expecting x is greater than 64, x equals 64 isn't going to work because the square root of 64 is equal to 8, not greater than 8. But we could also look at this as like, hey, wait a second, kind of like squaring both sides. So that's still going to be okay for an inequality. And it is. Okay, if we do that, then we're going to have the square root of x squared is greater than 8 squared. And the reason this preserves inequality is like if you have a bigger number, a number is bigger than a smaller number, and we square them, that the squares are both going to be like they're going to have that same ordering. I think provided that they have the same, provided that they're both positive. Yeah. So yeah, if we had like square root of x greater than -3, that might be one we'd have to think about a little bit more. I think we're going to avoid that case in Algebra 2. I think that's more of like a pre-calc consideration, or I don't know what class it is, but I don't think that's something we need to worry about here. Let me tell you the steps for solving these. Oh wait, because and then we're saying x is greater than 8 squared is 64. That's how I arrived at that algebraically, instead of just like, analytically or thinking about it or whatever. Okay, let me show you the steps. All right, so kind of like with the radical equations, we're going to take the same steps. We're going to isolate the radical. We're going to take both sides of the, now in our case, inequality to an appropriate power. We're going to solve the inequality. And with equations, what we always did was like, hey, if we squared both sides, we need to check our answer. This is essentially what we're doing. I'm going to call it consider the radicand, though. And I think it would just be easiest for me to show you what I mean in terms of an example. So the standard example would be square root of x less than 5. Okay. So if you kind of just like went along, in this case, we're going to square both sides again, will be the first step. I probably won't be showing this beyond this example right here. But I'm going to square both sides, and I'm going to get x is less than 25. In fact, great, this went really well. I liked this problem. Okay, so I radically took both sides to the second power. That solved the inequality. I didn't do the same thing to both sides. It wasn't like square root of x plus 1 where I'd subtract 1 from both sides. Nothing like that. Okay, so x is less than 25. But there's more to it than this, right? This is not true for all numbers, right? So I plug in x equals -1. -1 is less than 25, yet the square root of -1 is I. And I didn't tell you this about imaginary numbers, but it doesn't really make sense to kind of compare them with a relationship like less than or greater than or equal to or anything like that. The complex numbers are not well ordered like the reals are. Okay, so what we need to do is we need to consider the radicand. Okay, so it's like the domain discussion when you're graphing a square root function. Okay, so I guess for the same reason you would not need to worry about this for a cube root. I'd say, okay, over here I know that the square root of x is only defined when x is greater than or equal to 0. So I'd say, but also x is greater than or equal to 0. Okay. So x is less than 25 and also greater than or equal to 0. I don't know if anybody's told you this, but actually means and. Okay, if you think about it, logically speaking, but and mean the same thing, but just has like a little bit of inflection to it. Okay, so what we're going to do is we're going to say it could equal 0. It's got to be strictly less than 25. Okay, this would be a picture of our solution region. Okay, if I needed to write it as an inequality, I'd say 0 less than or equal to x less than 25. And if I needed to write it as an interval, then I would say 0 to 25, including 0, not including 25. So like probably one of these two answers, but really any of these three would be the values of x that make that inequality true. So I think I'm just going to work a couple of more of these for you, show you all the ways it can work out. And now this could go, it could be very different, right? If I had this, say less than or equal to negative 12, I'm pretty sure there'd be no solution. Greater than negative 12, I think, we're not going to get into the more complicated examples. If I'm being honest, I don't even think that this is exactly one of the things that we're required to do in Texas Algebra 2. But I think I would be remiss to show you how to solve radical equations and graph radical functions and not also how to solve radical inequalities in an Algebra 2 class. I think it's something we should do. So I'm going to go over here and I'm just going to isolate the radical, divide both sides by 3. So square root of x minus 1 is less than or equal to 4. Then I'm going to square both sides. Okay, and then I'll have x minus 1 less than or equal to 16. Okay, then I'm going to solve at x by adding 1 to both sides. And I'm going to get x is less than or equal to 17. But I need to consider the radical, right? I need to grab the thing in the original statement of the question, the x minus 1, and I need to set that greater than or equal to 0. Oops. Yeah, there we go. And so maybe I'll switch up the color here. I still got blue. So I would say, all right, x minus 1 is greater than or potentially equal to 0. I'm going to solve for x. I'm going to get x is greater than or equal to 1. So x is less than or equal to 17, and it's greater than or equal to 1. So that's from 1 up to 17, including both endpoints. We could write this as an inequality, 1 less than or equal to x less than or equal to 17, or we could write it as an interval, 1 to 17. Okay, I think I got 1 or 2 more for you. Yeah, we should definitely do one where it comes back greater than. Okay, so I'm going to go over here, and we actually already did one of those. It was just we didn't have to worry about any of our solutions causing us to take the square root of a negative number when I did square root of x is greater than 8. Okay, so this isn't really what we're working with here. I'm going to, same as before, isolate the radical, take both sides to an appropriate power. In this case, it's going to be squaring, and then solving for x. Okay. Now for me, I'm going to kind of do, I'm not going to be like, oh, you need to remember if it's greater than, okay, I could do things to this inequality to, I wouldn't try to look for any hard and fast rules. Say, let's just consider the radicand. All right, so x minus 1 over here. So go down here. I'm going to set x minus 1 greater than or equal to 0. Right. So I'm going to solve, and that's going to be x greater than or equal to 1, just like it was before. But if it's the case that x is greater than or equal to 1 and x is greater than 17, that's the exact same thing as just saying x is greater than 17. Because if it's greater than 17, it will already be greater than or equal to 1. So this is redundant in this situation. Now there are other ways that this can go, but I think that this is going to be a good place for you to start from. Okay, a good place for you to start your practicing on radical inequalities. If I'm going to write this as a sketch, I'm going to say, okay, it's everything bigger than 17. Okay, I could say x is greater than 17. That would be my inequality. And my interval would be from 17 up to positive infinity. All right, so yeah, I think that's going to be all. At this point, you should practice these on your own, work on them. If the ones I gave you on the homework aren't enough, go consult with Google, type in, radical inequality practice, and that should give you enough opportunities to practice until you're feeling confident. Thanks for watching.